In the last section, we looked at how to take a linear equation and graph it as a line in a picture. And now we're going to go essentially backwards, and we're going to take characteristics of the line itself, of that picture, of that graph, and we're going to turn it into a linear equation. Now, when we were graphing lines, we did see that using the slope-intercept form, we could take just a y-intercept and a slope, which is a steepness off that point, and with just those two pieces of information, we could get the picture of the line. And likewise, when we create the equation of a line, we can use just two pieces of information to get it. We're going to take a point, and it doesn't necessarily have to be the y-intercept, but we'll take a point, and then we will take the steepness that comes off of that point. We'll take the slope, and using the point and the slope, we have a formula that relates that information to help us get the equation of the line. So for an example, if we want to define the equation of the line, which passes through the point 5, 8, and has a slope of 3, we can use just those two pieces of information along with this formula to find the equation of the line. Now, before I start using the formula, what I will do is I will give the pieces of information I've been given, the characteristics of the line, I will give them special names so that I know how to plug them into the symbols in my formula. So when I'm looking at this formula, I see several different symbols. What I'll tell you is that the x and the y, which have no subscripts on them, those are going to remain just x and y. We've seen before that with linear equations, equations of lines, we will see the symbol x and the symbol y. So those guys are just going to stay put. But where I see the x and y with the subscript, those are going to be the coordinates of the point I've been given. So when I see x sub 1 in my formula, that's the x coordinate of the point I've been given, which in this case is 5. And in the equation or the formula where I see that symbol y sub 1, that subscript is telling me it's from the other coordinate of the point I have, which in this case the y coordinate is 8. And then the slope we've seen before is using the symbol m. So we're going to say m is 3. So we have x1, y1, and m. Those three pieces of information will now go into our formula to help us get the equation of the line. So what I'll do is I'll start writing my formula, I'll copy it, but where I see those symbols which stand for information I now have, I'll substitute that information in. So I have y minus, and then where I have the y sub 1, that's my y coordinate of my point, which is 8. And I'll make it a different color just so we can see where the plugging in or the substitution's happening. Equals, and then m is 3. And then I have parentheses x minus, and then I have x sub 1, which was the x coordinate of our point, which was 5. So this is just me copying the formula that I was given, the point slope formula, but where I had those special symbols which represented information I was given about the line, I went ahead and just plugged that in. And so now, I have a linear equation, it's now just going to be a matter of kind of cleaning it up and making it look a little nicer. So what I see on the right side is that there are parentheses trapping my information. Let's go ahead and remove those parentheses now. So on the left we have y minus 8. On the right we have 3 times x, which is 3x. We have 3 times negative 5, which is negative 15, and it looks like we're well on our way to getting the slope-intercept form, which is a nice form of the equation. We saw in the last video that if we have that form of the equation, it's really easy to graph the line. So let's go ahead and look for that slope-intercept form here, where we would need the y to be isolated. Let's remove and relocate that 8. Since it's currently negative 8, we will relocate it using addition. So we will add 8 to both sides of our equation. We wind up with y equals, we now have 3x that was still on the right side, but now negative 15 plus 8 will give us negative 7. And that is our slope-intercept form of the equation of the line that passes through the point 5, 8 and also has a slope of 3. In fact, looking at the equation, you can see that the slope here is 3. We also can see that the y-intercept is negative 7. We just weren't given that information up front, but now we see it. So this is our slope-intercept form. We saw in the previous video, this is just one way to write the equation of a line, one format of writing it. And it's a nice format to use because we can use the y-intercept and the slope to get our graph really easily. But there's another format that you might be asked to show when you're finding the equation of a line. Slope-intercept form is great, but you might also be asked to find what's called the standard form of the equation. So let's take a look at how we can take this slope-intercept form and change it to a different looking equation. It's the same information, it represents the same line, but it's just a different format called standard form. So the slope-intercept form of a line has the y isolated, and on the other side of the equation it has an x term and a constant term. The standard form of a linear equation is going to actually have both x and y terms on the left side with only the constant on the right side. More than that, the x and y have coefficients which are whole numbers, not fractions, and more specifically, the x has to come first with a positive coefficient. So there's several different things we need to check for as we change from slope-intercept to standard form. What I'll do is I will begin by writing down my slope-intercept form, which is in this example, y equals 3x minus 7. And as I move towards standard form, I have a few things to check for. Number one, I need x and y both on the left, the constant on the right. And so in this case, who would move is the 3x. Since he's currently positive, I will relocate him by subtracting. And so now on the left side, I will have negative 3x with that positive y. And on the right side, I have negative 7. So first things first, I do now have x and y on the left side. So that's one thing taken care of. Number two, I need to make sure that I have no fraction coefficients in front of x or y, and that's the case here, so I'm good. And the last thing to check is that x is leading with a positive coefficient. In this case, x is leading with a negative, so that's a problem. If I want to change this sign, I'm going to have to change everybody's sign. So what I'll do to change the sign is I can either say, well, hey, there's a negative attached by multiplication. What I can look at this as is let's detach that negative by dividing. I'm going to divide by negative 1, and if I divide everybody by negative 1, that's just saying let's change everybody's sign. It's fair and balanced as long as it happens the same way to every term. So negative 3x becomes positive 3x, positive y becomes negative y, negative 7 becomes positive 7. So let's check our three things again that we need for standard form. We need x and y on the left, which we have. We need no fraction coefficients. We need whole number coefficients on x and y, which we have. And last, we need to make sure x is positive leading in front, which we now have. And so this is going to be the standard form for the equation which passes through the point 5, 8 and has a slope of 3. We had already gotten the slope-intercept form. We now have the standard form as well. So just watch the directions as you're doing your homework. Sometimes they'll ask for the slope-intercept form of the equation. Sometimes they'll ask for the standard form of the equation. Sometimes they don't specify, and you can pick. If I were to pick, I'd probably just do slope-intercept. I find that to be a very useful form because it's nice to graph from. But there is not one form that's more right or more correct than the other. They say the exact same thing, it's just a different format. So again, this was the slope-intercept form where y is by itself on one side. This is the standard form where x and y are on the left together. There are no fractions on this left side, and the leading term is positive. So let's take a look at another example. Okay, so for this next example, we want to find the equation of a line which passes through the point 3, negative 2 and has a slope of negative 2. So again, what I want to do before I start plugging things in, I just want to identify who's going to go where. What are each of these pieces of information going to represent? So going up to my formula up here, I know that I have an x1 I need to identify, I have a y1 I need to identify, and I have a slope m that I need to identify. So x1 and y1, again, these are the coordinates of the point you've been given. So x1 will represent 3 from this ordered pair. y1 will represent the negative 2 from this ordered pair. And m will represent the slope, which is also negative 2. So once I've identified those key pieces of information, now I can go ahead and plug them into my formula. So I've got y minus, and then I need my y1, which was negative 2. And this is where we'll need to be careful here because I'm going to be subtracting negative 2. Eventually that will turn to a plus. So now I've got equals, and I need the slope m, which we said was also negative 2. And then we have parentheses, x minus x1, and x1 we said was 3, the x-coordinate from our given point. So there is me copying the formula but plugging in the information I've got. And so now we just want to kind of clean this up a little bit. Let's first write it in slope-intercept form, and then we'll take a look at how to change that to standard form. So first, let's rewrite this left-hand side to make it a little bit cleaner. Instead of y minus negative 2, let's call this y plus 2. And then on the right side, let's go ahead and distribute to remove these parentheses, loosen things up a bit. Negative 2 times x will be negative 2x. And negative 2 times negative 3 will be positive 6. So we're almost there. To get slope-intercept form, we want to isolate y, so the only thing left to do is to relocate that constant 2. Since it's positive, I'll relocate it with subtraction, and it's fair as long as I do the same thing to both sides. So now y has been isolated on the left, and then on the right we have negative 2x. And then 6 minus 2 will give us positive 4. And so now that y has been isolated, this right here is going to be my slope-intercept form. And using that form, I can identify the slope, which is negative 2, which is what we should have had, so that's good. So there's my slope. I also have a y-intercept if I was interested in knowing that extra point. So now I actually know 2 points on this line, 3 comma negative 2, and also the y-intercept 0 comma 4. That's the slope-intercept form. Let's take a look at how to change that to standard form just in case we're asked to find it. Okay, so as we're changing from slope-intercept form to standard form, remember there's really 3 things we're looking for. We want to first make sure x and y are both together on the left side of the equation. We want to make sure there are no fraction coefficients on x or y, and we need to make sure that x is leading with a positive sign. So as we're looking at this slope-intercept form that we got, y equals negative 2x plus 4. Let's begin by relocating the x term so that it's joining the y on the left. Since it's currently negative, I'll go ahead and add 2x to both sides. And so now on the left side, I have a positive 2x. I have a positive y. And on the right side, the x's are gone. All I have now is the constant 4. I think this actually looks good. So again, let's look at our 3 conditions. We need number 1, x and y on the left, number on the right, which we have. Number 2, we need to make sure there's no fraction coefficients in front of x or y, which we have, only whole numbers. And then the third is we need to make sure x is positive, which it is. So we're actually done with just that one relocation step. Here is the standard form of the equation, which passes through the point 3 comma negative 2 and has a slope of negative 2. So again, we have 2 different ways that we could write this equation. There's the slope-intercept form where y is isolated, and there's the standard form where x and y are showing up together on the left. There is not one that's more correct than the other. It's just 2 different ways to say the exact same thing. So let's look at one more example with maybe a fraction. Okay, this last example, we're trying to find the equation of the line which passes through the point negative 9 comma 4 and has a slope of negative 4/3. Now that negative 4/3 is a fraction, so we'll see how that comes out in the end here. First, before I start plugging and chugging, let's give each of these pieces of information a name. I know that there's an x sub 1, a y sub 1, and an m from my formula that I need to be able to plug in, so I have to identify those pieces. X sub 1 is the x coordinate of your point that you're given, so that's negative 9. Y sub 1 is the y coordinate of your given point, which is 4. And m is your slope, which is negative 4/3. So then we'll take those pieces of information, we'll plug it into our formula. So I've got y minus, and then where I see the y1, I'm going to put the value 4. That's our y coordinate we were given. Then I have equals m. So in this case, that's equals, and then m, our slope was negative 4/3. And then I have parentheses x minus, so I'll copy that. And then my x1 coordinate was negative 9. Again, watch your signs. We are subtracting -9. So the subtraction came from the formula, the -9 came from the point. So let's clean this up a little bit. I think what I might want to do first is handle this minus a negative. Let's change that to a plus sign. So I've got y minus 4 equals -4/3 x plus 9. Minus a negative is just plus. And then I see those parentheses as we have before. Let's get rid of the parentheses by distributing. So I'm going to keep that left side the same. We've got y minus 4 equals, and now -4/3 times x, that's just going to be -4/3 x. No big deal there. But -4/3 times 9, we may want to go off to the side to work that a little bit. If I have -4/3 that I want to multiply by the number 9, let's rewrite 9 as 9/1. And remember, fractions are multiplied straight across. Negative times positive will be negative. Straight across upstairs, 4 times 9 will give me 36. Straight across downstairs, 3 times 1 will give me 3. So I have -36/3, but that reduces nicely. 36 divided by 3 is just 12. So I wind up with a nice number. Even though I had to deal with the fraction up front, it actually turned out not so bad. So we've got -12 for that -4/3 times 9. And so now for my last step to try and write this in slope-intercept form, getting the y by itself, I want to relocate that 4. Since it's currently negative, I will add 4 to both sides to relocate it. Remember, whatever you do to one side, you do to the other to maintain the balance. So now I have y by itself on the left. On the right, I have that -4/3 x. And then -12 plus 4 will give me -8. And there is my slope-intercept form. I'm going to need to have some space here. Here's my slope-intercept form of the line that goes through -9, 4 and has a slope of -4/3. It happens to have a fraction in my answer here. I don't care about that for slope-intercept form. All I care about in slope-intercept form is that y is by itself. I can see the slope as rise over run, so it doesn't bother me that this slope is a fraction. That's totally fine. I can see my y-intercept is 0, -8. So I'm happy with the way that looks. But if the instructions asked us to write it in standard form, this is where it gets a little fun. Let's see how it works. So remember, as we're changing from slope-intercept form to standard form, we have 3 things to keep in mind. In standard form, we want x and y together on the left, we want no fraction coefficients on them, and we want x to be positive. So let's see how it works here. Let's begin with our slope-intercept form, which was the y equals -4/3 x minus 8. First things first, let's get x and y together on the left. So that means taking this -4/3 x and relocating it to the other side. So what I will do is I will add, since it is negative, I will add 4/3 x to both sides. That's going to leave me with 4/3 x plus y on the left, and on the right we'll have just the -8. So of our 3 things to watch for, number 1 we've taken care of. X and y are now both on the left side. Second thing we need to watch for, though, is that we need to make sure we have no fraction coefficients, and unfortunately here we do. We have 4/3 that's in front of x. Now there's an interesting trick here. I can multiply equations by whatever I want on either side, as long as I do it to both sides. Is there anything I can multiply this by to make that fraction go away? Well, the nice easy trick is if you can multiply by the denominator itself, that fraction will no longer be a fraction. Let's see how that works. I'm going to suggest that we multiply by the denominator 3. If we do that on the left, we do have to do it on the right, because again, we have to maintain our balance. But watch what happens. When I distribute here, 3 times 4/3, let's do that off to the sides. And let's write 3 as 3/1. If I times 3/1 times 4/3, remember we go straight across. 3 times 4 is 12. On bottom, 1 times 3 is 3, and 12/3 is just 4. So when I multiply 3 times 4 over 3, essentially those 3's are canceling each other out and I'm left with just that 4. So when I multiply 3 times 4/3 x, I'm just going to get 4x. But we have to be careful because getting rid of that fraction changes its value, and I have to make sure I do the exact same thing to everyone else to maintain that balance. So I also have to do 3 times y, which will give me 3y. And then on the right, I need negative 8 times 3, which is negative 24. So I have multiplied everybody by 3 to maintain that balance. So let's go through our checklist again. Number 1, we need to make sure x and y are on the same side on the left. We've got that. Number 2, we don't want fractions in front of x or y, which is true here. And number 3, we need to make sure x is positive, which it is. So here is our standard form. So if you ever have fractions and you need to get rid of those fractions for your standard form, go ahead and multiply by the denominator and it'll make the fraction go away. There is our now standard form for the equation that goes through the point -9, 4 and has a slope of -4/3. And again, the slope-intercept form and the standard form, they are the same line. They represent the exact same picture. They just look quite different. So their formats are different, but they say the exact same thing. Let's look at one more example where instead of being given a point and a slope directly, maybe we have to do a little bit of work to get that information. So for this last example, we're shaking things up a little bit. Rather than giving you a point and a slope to directly plug into the point-slope formula, in this case, we're being given just 2 points. Find the equation of the line which passes through the points -2, 12 and 0, 2. Now, if you think about the graph, if you had 2 points on your graph, you could connect the points and get a line. So 2 points is enough information to get a line. It should be enough information to get the equation of the line as well. So here's how we're going to do it. Since we haven't been given the slope explicitly, we can take the information from these 2 points and we can find the slope. Here's the formula for finding a slope. It's y2 minus y1 over x2 minus x1. It's the difference in y values, which is vertical movement, over the difference in x values, which is the horizontal. So essentially your slope is that rise over run idea again. So what I'm going to do is I'm actually going to label here my first point that I'm given. I'm going to label that as x1 and y1. The 1 as a subscript is just saying that's my first point. And then here I'm going to take the labels x2 and y2 to say those are the x and y values from my second point. So the subscripts are just saying here's a point or here's a second point. But I'm going to take those 2 pieces of information from each point and I'm going to plug them in here and see what happens. So my slope is y2 minus y1. That's going to be 2 minus 12 over x2 minus x1. So that here is 0 minus negative 2. Remember that 0 minus negative 2 would just mean 0 plus 2. So I have 2 minus 12 over 0 plus 2. 2 minus 12 will give us negative 10. 0 plus 2 will give us 2, and we can simplify negative 10 over 2, calling it just negative 5. So we actually have a slope of negative 5, and then we have these x's and these y's. That's enough information now to plug into my point slope formula to find the equation of this line. So let's start that point slope formula, y minus. Now we need to plug in our y1 value, which we labeled as 12. And then equals m. We just calculated m using this new formula. We said m is now negative 5. And then I need parentheses x minus. And then where I see the x sub 1, that I labeled for my negative 2. Remember, when you have a minus negative, be really careful there. So let's clean up that minus negative. I've got y minus 12 on the left equals negative 5, and in parentheses, this is really x plus 2. So let's keep working on this equation. Let's clean it up a little bit, get it in that slope-intercept form. We want to first release things from parentheses, so let's get rid of parentheses by distributing. We'll then have y minus 12 on the left still. On the right, we'll have negative 5 times x, which is negative 5x. We'll we'll have negative 5 times positive 2, which is negative 10. And then last for that point slope formula is to isolate the y. We want to move that 12 since it's currently negative. We will add that 12 to both sides. And so now the left is just the isolated y, which we need for that slope-intercept form. And now I have negative 5x. And then negative 10 plus 12 is positive 2. So there is my slope-intercept form for the equation of the line that goes through these 2 points. So if you have a point and a slope, you can plug it right into that point slope formula, but if you don't have an explicit slope given to you, all you have are 2 points, you can still take those 2 points and calculate a slope, and then you can use that slope to plug into your formula. Now for one last step, let's see if we can take that equation and write it in standard form, and then we'll be done. So again, remember that we have slope-intercept form and we have standard form. There's not one that's better than the other. It's just 2 different ways to express the same information to describe the line that we're talking about. So I have my slope-intercept form. Let's see if we can change it to standard form just in case those directions ask us to. I begin by rewriting that slope-intercept form so I have a starting point. And then as I move from slope-intercept to standard, again, I've got 3 things to watch for. For standard form, I want x and y together on the left, I want no fractions in front of them, and I want a positive on the x. So to get x to join y, let's relocate it. Since it's negative, I'll add 5x to both sides. And so now on the left-hand side, I've got a positive 5x joining that positive y. And on the right, I have that constant 2. And with just that one step, I did succeed in getting x and y together. I also have no fractions in front of them, and x happens to be positive. So just with that one step, we are done. And here is our standard form for the equation of this line. So pay attention to the directions. Sometimes the directions will ask for the slope-intercept form where you want y by itself. Sometimes it'll ask for standard form where you want x and y together, no fractions, positive leading term. And sometimes the directions won't say anything about the form. It'll just say, hey, come up with an equation, and it won't matter. You get to pick whichever one you want. I normally would pick this because that's where I go naturally, is the slope-intercept form. Sometimes standard takes a little bit of extra work. So if you have the choice, you might just leave it at slope-intercept form. But if you're told to work it to standard form, you now have some examples that you can refer to help you do that.